Hi guys, we are working on the Riemann sums as an integral and limit statements. These were always challenging, but they're not going to give you any hard ones on the AP exam if they, and I really would make sure you go through this lesson carefully, work on the circuit training by yourself, and then I'm going to record how to do the circuit training. So if you can't figure out how to do one from the paper, you might figure out how to do it by me discussing it. Now maybe you only have to listen to a couple and then you can move on, because it's very repetitive. There's only going one way and then going the other way, and it'll be back and forth the same procedure each time. So let's review this and make sure we understand it all. Okay, so what we're talking about is coming up with a Riemann sum that this is the actual thing we're trying to do. Now let me explain. The integral, the actual area under the curve, can also be written as a limit, as n goes to infinity of a sum. And you remember this, we did these, k equals 1 to n, and then you have the function, and it's summing it up, x to the k and delta x. And so this is the exact same thing as the derivative of a to b of f of x dx. And we have to be able to see this and write this, or see this and write that, okay? And so I'm going to walk, and we're going to do, the circuit training has 16 of them on there. You're going to know how to do it by the time you finish this lesson, okay? And then you don't have to worry, that's plenty of practice, as long as you did it on your own and struggled and worked through it. All right, so there's some things that'll help us remember what to do. So delta x is the first thing you always do. I always put like a 1 there. And that is the total distance, which if this is A and this is B, the width of each rectangle would be the total distance divided by the number of rectangles. So that's all that is. Delta x is B minus A over n. Total width, this is the total width, divided by the number of rectangles. So that gives you the distance each one is, okay? So, all right, that gives you the width. And then each step interval, okay, do you remember, you want to see what you do with the x. So if you have a function like x plus 2, what do I put in place of that? That's the second step you do. And if you remember, it's a plus delta xk, which is what this is right here, a plus delta xk, where k is the first rectangle, and the next one, k equals 2, would be the second rectangle. And by the way, this is a right. If we were doing this, they always give it to you in the right form. If it was 0 to n, it would be a left. So, okay, a plus delta xk is what goes inside the x. So I would replace this x with a plus delta xk, okay? And so then this is just the x value. And so if I want to know what the height is, I have to take f of that. And that's what we're saying here. The height is f of xk delta x. F of xk, and then the area is the width, which is delta x, and then the height, which is f of xk. Okay, so then we put all that together and sum them, so we add up all these rectangles, and we get an approximation. So, that would be a right Riemann sum. Now, if you want the actual area, you take the limit as the number of triangles goes to infinity, so that I get more and more triangles and they're smaller and smaller, okay? So, and then you take the sum of that, and by the time we're done with that, we can turn it into an integral. So let's do an example so you can see me working it out little by little, and I think it'll become clear. Sometimes just going over it in general doesn't help, specifics really help. So let's get an example I have, okay? So we want to rewrite this as a definite integral and evaluate it. And so it doesn't look like this is a definite integral, but that's what you've got to recognize. This guy right here, you need to know that that turns into an integral, okay? The limit as a number of triangles go to infinity of a sum of rectangles, not triangles. If I said triangles, I meant rectangles. As the number of rectangles goes to infinity, I'm going to sum up those rectangles. Okay, so how in the world do I turn this into something that looks like this, a to b f of x dx? Well, here's how you do it. The first thing you do is you realize that the formula was, this is the f of xk, and this is the delta x. Oops, I said delta k. This is the delta x. So remember, the first thing we knew was delta x is equal to b minus a over n. Now, we also know, so if you're trying to figure out what b and a are, you don't really know. You just know so far that b minus a is equal to pi from this right here, okay? Now, but a is, you remember, in the function, what do you put into the function? So I always call this step number 2. A plus delta xk is what goes into the function. So if I had like an x squared plus 3, I would put a plus delta xk and then squared plus 3, right? So what do we do when we have the function? We have to actually look at it and see, okay, look. This looks like 3 cosine something plus 5. So I'm willing to bet that my function is 3 cosine, just putting this over here, of x plus 5. Okay, so my x looks like it's this right here. And the x is supposed to be x equals a plus delta xk. So, all right, first of all, do I have a plus in that? No, so a must be 0. And that's often what it is. A is 0, but it doesn't have to be. We'll get to some that aren't. And then delta x we already knew was pi over n from that right there, like here, okay? So 0 plus pi over nk, is that what I have in there? It sure is. So x is equal to pi over nk. So there's where you can see me seeing that it's 3 cosine x plus 5. So that means that a was 0. Go back up here. If a was 0, then b minus 0 is pi, so b equals pi. Now, why do we care? Well, we need a to b, right? This is a to b of f of x dx. So far I've got the function 3 cosine x plus 5 dx, and I know it goes from a to b. A was 0, and b was pi. So I'm not going to evaluate it right now. I just want you to be able to write that from that. Okay, now, that's all I'm doing as far as the notes. Now I'm going to actually start doing the circuit training and do a few, and then you listen to me, and then you go try to do the circuit training, okay? So work hard on this. Make sure you turn in the circuit training. You don't have to turn in these notes. Just turn in the circuit training and make sure you give it a good try, okay?